AOPS counting and probability 11.16. Two possibly equal integers x and y are chosen at random such that x is in between 1 and 5 and y is in between 1 and 5. What is the expected value of the area of the triangle with vertices 0, 0, x, 0, and 0, y? So the area of this triangle is x times y divided by 2, which is 1 over 2xy. So there are 25 ordered pairs of x and y because x and y can be in between 1 and 5. So it's like 1, 1, 1, 2, 1, 3, all the way to 5, 5. So the expected value is 1 over 25 times 1 over 2 times 1 times 1 plus 1 over 2 times 1 times 2, because these are the areas of the triangles. So, and you multiply it by 1 over 25 because it's the probability of each of these areas of the triangles. So this calculation is equal to 9 over 2. AOPS counting and probability 11.17. A bin has 2 white balls and 3 black balls. You play a game as follows. You draw balls at random out of the bin, one at a time without replacement. Every time you draw a white ball, you win $1, but every time you draw a black ball, you lose $1. This looks bad for you since there are more black balls than white balls, but you are allowed to stop the game at any time. Devise a strategy for playing this game which results in an expected profit. So you should stop drawing if you draw a white ball first, and if a black ball is drawn, continue until both white balls are drawn, because the probability, this is the drawing sequence and this is the win. So if you draw a white ball first, then it says stop drawing. So we're saying pretend you get white and then black and then black and then black after, so you win $1. And if you draw white first and then pretend you win a black, 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 white after, you still win $1. And white and then black, white, black, black, $1, white and then black, black, white, black is $1. Then if you draw a black ball first and then you draw the 2 white balls, you stop after the 2 white balls are drawn, so you have to get a black and a black after, so your win is $1. And if you draw black, white, black, black, white, it's -1. Black, black, white is -1. Black, white, and the last one, you can stop drawing here, so the last one, it has to be black, except you don't draw it, so it's $0. And black, white, with no black, but you're supposed to get a black, but you stop drawing, it's $0, and black, white is -$1. So any of these sequences has 1 over 5 choose 2, which is a 1 over 10 chance. So 5 over 10, which is 1 over 2, you win $1. 2 over 10, which is 1 over 5, it's even, $0. And 3 over 10, you lose $1. So the expected profit is 1 over 2 times $1 plus 1 over 5 times $0 plus 3 over 10 times -$1, which is 1 over $5. So that's your expected profit. AOPS counting and probability 11.18. A coin is weighted so that it comes up heads with probability p and tails with probability 1 minus p for some value p such that p is in between 0 and 1. I keep flipping the coin until heads comes up. What is the expected value of the number of flips necessary? Express your answer in terms of p. So the probability that the coin first comes up heads is p. The probability that the coin comes up heads second is 1 minus p times p. And the probability that heads comes up first after n flips is 1 minus p n minus 1 to the n minus 1 power times p, because if it's the first heads, then the previous ones must all be tails. Tails probability is 1 minus p, so 1 minus p to the power of n times n minus 1, because that's the number of flips, times p, which is the heads. So the expected probability is 1 times p plus 2 times p times 1 minus p plus 3 times p times 1 minus p, 3 times p times 1 minus p to the power of 2, etc., all the way to n plus 1 times p times 1 minus p to the power of n. So 1 minus p times the expected probability is equal to 1 times p times 1 minus p plus 2 times p times 1 minus p to the power of 2, all the way to n plus 1 times p times 1 minus p to the power of n plus 1. So if you subtract e's and e minus 1 minus p to e, it's equal to p plus p times 1 minus p plus p times 1 minus p to the power of 2 all the way to p times 1 minus p to the power of n. So the expected probability E is equal to 1 plus 1 minus p plus 1 minus p to the power of 2 all the way to 1 minus p to the power of n, which is equal to 1 over p.